Cartography is the process of studying, creating, and designing maps. It helps us to locate and understand how our world is with only an illustrations. Its words represent our world with just an image on a paper or in a device. Maps have been created and traced back in 5,000 years ago by Anaximander, who was a Greek. The Greek used a mathematical base as its creations. Before it was drawn on a paper or it was illustrated on a device, right? How now we are looking on the map. Last time it was drawn on a wall or a stone or in the cave. The oldest map in the world is a Babylonian map of the world, or also known as Imago Mundi. It is the oldest map that can still be seen nowadays in a British Museum in London. It was created between 5,100 and 700 BC and discovered in a town in Iraq. Another oldest map in the world is the Continental Planisphere that was kept in the Gallery Aston in Italy. In this map, we can see how it was presented to illustrate Arctic equator and border of Portuguese and Spanish. With the creation from ancient time and the increase of map making by scholars and philosophers around the world, we now can enjoy the easiest way to understanding Earth through them by utilizing modern devices. In this report, we will learn the basics of cartography and how it can be used.
Geographic coordinate system for determining places on the Earth that use a three-dimensional spherical surface. A geographical coordinate is one of the two lines of latitude and longitude that connect to determine a location's geographical point. And the figure is show the geographic coordinate system. And the positive latitude are found north of the equator and range from 0 to positive 90 degree. And negative latitude are found south of the equator and range from 0 to negative 90 degree. Planimetric coordinate system. A planimetric coordinate system is a two-dimensional representation of the Earth that is a flat and two-dimensional. It's based on a sphere and spheroid geographic coordinate system, but it employs linear unit of a measure for coordinate, allowing distance and area computation to be done quickly using the same unit. On the flat projection, the latitude and longitude coordinate are converted to x and y coordinate. The y-axis is the central line that runs east and west, and the y-axis is the central line that runs north and south. And the origin is located in the intersection of the x and y-axis and has a coordinate of 0.0. And the figure is show the planimetric coordinate system. Comparison between geographic coordinate system and planimetric coordinate system. Geographic coordinate system. A geographic coordinate system is a reference framework for locating features on a model of the world. It's a three-dimensional, and the shape of the geographic coordinate system is a globe or spherical. Unit of a geographic coordinate system is degree, minute, and second. And geographic coordinate system is based on latitude and longitude. For example, World Geodetic System WGS 84. Planimetric coordinate system. A planimetric coordinate system is a flat coordinate system containing a geographical coordinate system. Use a map, which is the projection algorithm and other parameters to convert the geographic coordinate system into a flat surface as a two-dimensional, and the shape of the planimetric coordinate system is the flat surface. Unit of the planimetric coordinate system is a meter and is based on map projection. And for example, Universe Transversal Mageddon UTM. Datum. A datum is an Earth model that used in mapping. A datum is a series of numbers that define the shape, size, and orientation of the ellipsoid in space. A datum is a reference frame that allows the coordinate system to describe position in three-dimensional. Datum can be divided into geocentric datum and local datum. The origin of an geocentric datum is the Earth's centre of the Mars, and the local datum spheroid is aligned to closely fit the Earth's surface in a specific area. A point on the spheroid surface corresponds to a specific location on the Earth's surface. This is referred to as a datum's origin point. Datum Malaysia. Malaysia geodetic datum has been established since the 19th century using the traditional surveying technique and procedures. Peninsular Malaysia and East Malaysia have separate classical non-geocentric geodetic datum known as the Malayan Reverses Triangulation 1948 and Borneo Triangulation 1968. The geocentric datum of Malaysia 2000 is a static datum created in 2003 by Jambatan Ukur dan Pemetahan Malaysia to create a homogeneous coordinate system in Malaysia that is compatible with the global reference frame. The primary goal of introducing GTM 2000 was to replace the traditional non-geocentric MRT 48 and PT 68 datum and to allow the compatibility and integration with modern centimeter-accurate space based on positional technology. Geocentric datum Malaysia. The Malaysia geocentric datum was defined by a set permanent GPS station known as a Malaysia Active GPS Station (MAS), getting highly accurate geocentric coordinate for the 70 MAS station and defining the Malaysia geocentric datum. And the figure is shown the Malaysia Active GPS Station (MAS). North American datum and global datum. North American datum 1927, the Clark 1966 spheroid is used to describe the form of the Earth in the North American datum 1927. The origin of this datum is a metal strange in Kansas, which is located on the surface of the Earth. North American datum 1983. The Geodetic Reference System 1980 spheroid was used to create the North American datum of 1983, which is based on both an Earth and satellite data. World Geodetic System 1984. The National Geospatial Intelligence Agency of the United States defined and maintaining the WGS-84 is a global datum, which means that coordinate for object fixed in the ground change over time. Greenwich is at as a starting point of a longitude in the WGS-84 coordinate system with degree as a unit.
In map projection, it consists of three basic projections. One is cylindrical projection, second is plane projection, and the third is conical projections. Cylindrical projection. It was introduced by Johann Heinrich Lambert along with 6 other projections in 1772. It has a straight coordinate line with horizontal parallel crossing the meridian and right angles. The scale is constant along each parallel and all meridians are equally spaced. The shape is rectangle, so it can be rolled up and their edge mapped in a tube or cylinder. The lines near the equator are accurate, but when it close to poles, it becomes distorted. In cylindrical projection, it consists of 3 types. One is equatorial or normal, the second is transverse, and the third is oblique. And the normal one or equatorial, it can be tangent and secant cylindrical. The tangent and secant lines are essential because the scale is maintained along this line, resulting without any distortion. Moving away from the normal line will cause more distortions. The second is transverse. The transverse is the cylinder is aligned perpendicular to the Earth axis with its middle on the chosen meridians. For the oblique, it locates along a great circles in between the equator and the meridian with an orientation larger than 0 degree but much less than 90 degree. Equatorial or normal cylinder. It consists of 2 types of cylinder. One is tangents and one is secant. For the tangents, the circumference of the cylinder reaches the surface of the reference globe along a huge circle in the tangent, which means that the cylinder diameter is the same as the globe diameters. For the second cylinder, the cylinder diameter is much smaller than the globe. The second lines are produced at the location where the cylinder cut through the globe. Plane projection, or it also known as azimuthal or zenithal projections. It consists of two. One is secant, one is tangent. For the tangents, it connects to the globe with a point. For the secant situations, the plane contact the Earth in a small circles by forming a common parallel with real size. Parallels are represented as concentric circles, and the meridian are projected as straight line for the map center. The distortion for the tangent scene is quite low because it's near the point of tangent C. Conical projections. Conical projections look like we are setting a cone above a globe. When the surface of the cone meet with the globe, it will form a latitude line or standard parallel line. And on that line, there will be no distortions. So they will cut the center of meridian to open up for the map projections. It cannot be used as a whole map, but it can be used as a regional map. The distortion will expand when it goes to the north and south of the cone. In coordinate system, there are two types. One is 2D and another is 3D. For the 3D, it has two, which is 3D Cartesian coordinate system, and another is 3D geographical coordinate system. For the 2D coordinate system, we have 2D Cartesian coordinate system and 2D geographical coordinate system, and lastly 2D polar coordinate system. Cartesian coordinate system. Cartesian coordinate system, it was drawn on a plane on a specific point. It can be positive, negative, or both. The unit is length or distance, which is in meters or miles. In Cartesian coordinate system, they have 3D and 2D. For the 3D, they have x, y, and z axis, while in 2D, it's only have x and y axis. The 3D, it will show us our coordinate on Earth, while for the 2D, it will only show our coordinate on a paper, which is on a map. Geographical coordinate system. In geographical coordinate system, it uses longitude and latitude. Its unit is degree, minutes, and seconds. For the latitudes, the minimum is 0 degree and maximum is 90 degree. Their starting point is on the equator, so the answer can be in north or south. For the longitudes, minimum is 0 degree and maximum is 180 degree. Its starting point is on prime meridian, so their answer can be on the west or on the east. In geographical coordinate system, it has 3D and 2D. For the 3D, it has latitude and longitude, and another is height. For the height, it uses meters. To look on the height, we need to see on the ellipsoid surface. If the height is above ellipsoid surface, it means that the number is positive. But if the ellipse was under ellipsoid surface, it means that for the topography to the ellipsoid surface, it did not reach the ellipsoid surface, it will be negative. For the 2D, it only has latitude and longitude. 2D polar coordinate system. 2D polar coordinate system, it was based on x and y axis. It takes distance from origin to point xy and angle between x and point xy. WGS-84. WGS-84 is a world geodetic system that is used by a global positioning system or GPS for coordinate system with 3D dimension frames. It used 3D Cartesian coordinate system, which is X, Y, and Z axis. WGS-84, it was a geodetic datum and terrestrial reference system that is focused on the Earth. Last time, it was known as WGS-1984. WGS-84 was created and maintained by the United States National Geospatial Intelligence Agency in the year of 1984, and it was revised back in 2014. This WGS-84, it can be used with the International Terrestrial Reference System, or ITRS.
Hello, my name is Andy and I'm going to present the remaining parts of our assignment. So now let's get to know about MRT first. What is MRT? MRT in the full name is Malayan Revised Triangulation. It is the coordinate system used for mapping in Peninsular Malaysia. The datum is based on the old result triangulation and computed using data collected mainly in the period 1948 to 1966 using the modified average soil, and the point of origin is in Bukit Ketau. It consists of about 1,200 stations plus a number of more recent standard travels and has an interstation accuracy of around 13 to 15 parts per million. Coordinates in this system are known as MRT-48 coordinate, which represent a unified datum, alphabet, and distort for the whole peninsula. Uh, let's discuss a little bit about the development of MRT-48. The 1880th century marks an important phase with the commencement of widespread trigonometric works in various parts of Malaysia, including a triangulation survey in Penang in 1832. The trigonometric survey in Perak, together with Penang and Province Wesley triangulation, as well as Malacca triangulation, between 1886 and 1888 laid the foundation for existing control fragment. This was followed by the commencement of other trigonometric surveys in various parts of the country that include Selangor and Negeri Sembilan. However, the earlier works were so inconsistent and of questionable quality that it was decided to observe the principal triangles of the general triangulation with the object of bringing it up to the modern standards of that time. This triangulation scheme in Peninsular Malaysia, which was completed in 1960, is known as the primary result triangulation. The primary or result triangulation was later replaced by a new system known as Malayan Reverse Triangulation. 1948 is what we are talking about just now. This was subsequently followed by a lengthy process of additional measurement and recomputation until 1968, which eventually resulted in a system referred to as MRT-68. The MRT-68 network consists of about 77 geodetic, 240 primary, 837 secondary, and 51 tertiary stations. It is based on the conventional observation, which with many of the triangulation points detected as far back as 1885. The MRT-68 has been adopted as a result of the recomputation of the earlier network together with the primary or result triangulation carried out between 1913 and 1916. The slide I'm showing now is the reference average soil for MRT-68. MRT-68 have the reference average soil, and that is modified Everest and is the same one as the MRT 48. The origin of MRT 68 is still remains the same, and that is Kertau at Pahang. The semi-major axis A for MRT 68 is 6377.304.036, while the semi-major axis B is 635756.103.039. The flattening for MRT 68 is 1 per 300.8017. Okay, now we are discussing about the RSO. The rectified skew automorphic map projection is an oblique Mercado projection developed by Houghton in 1947, Snyder 1984. This projection is automorphic, conformal, and cylindrical. All meridians and parallel are complex curves. Scale is approximately 21 true along a chosen central line, which is exactly true along a great circle in its spherical form. It is thus a suitable projection for an area like Switzerland, Italy, New Zealand, Madagascar, and Malaysia as well, and it is one version of the oblique Mercado projection derivation. Okay, now we talk about the properties and the limitation of rectified skew automorphic. One of the properties of RSO is that this projection is an oblique cylindrical projection from the aspect reticule. In general, the meridians and parallels are projected as complex curves. Only two meridians, exactly 180 degrees apart, can be projected as straight lines and crossing the poles. Both poles are presented as points inside the projection outline. Okay, now the second properties. The RSO is appropriate for mapping large scale or smaller areas with oblique orientation and do not follow a north-south or east-west predominant extent from aspect of usage. The third property about the RSO is it is a conformal map projection because it does not maintain the true direction, but angles and shapes can be maintained at infinitesimal scale. Distances are accurate along the central line if the scale factor is 1.0. If it is less than 1.0, there are two straight lines parallel to the central line with accurate scale, area, distance, and scale. Distortion greatly increases with distance from the central line or form the two straight lines that are parallel to the central line. However, this projection has a limitation, and it is the implementation of this projection in ARGIS is limited such that approximately 1 degree of latitude and longitude around the antipodal point cannot be shown. When using ellipsoids, constant scale along the central line or along straight lines parallel to the central line is not maintained. Okay, now we are discussing this application of RSO. The rectified skew automorphic projection has been used for mapping large scale or smaller scale with the oblique orientation and do not follow a north-south or east-west predominant extent. This position is used for coordinate system in Malaysia and also Borneo. Now we are asking why Malaysia use this projection too, and it is because RSO can provide an optimum solution in the sense of minimizing distortion while remaining conformal for Malaysia. Now we are discussing the last projection for our assignment, and it is Cassini-Somnia. This projection was described by Cesar Francois Cassini di Terri Uh, and he stated that it was a map projection in 1745. He stated that it is the transverse aspect of the equirectangular projection, in that the globe is the first rotated, so the central meridian becomes the equator, and then the normal equirectangular projection is applied. What are the properties and limitation of Cassini-Sonia? One of the properties of this projection is it does not have any distortion along the central meridian, and the distortion increase with distance from the central meridian or from the aspect of shape and area. Besides, the scale distortion increase with distance from the central meridian. However, scale is accurate along the central meridian and all line perpendicular to the central meridian from the aspect of distance, while the direction on the map will be generally distorted from the aspect of direction. Now, the main limitation of this projection is that it is used primarily for large-scale mapping of areas near the central meridian. The extent on a spheroid is limited to 5 degrees to either side of the central meridian. Beyond that range, data projected to Cassini-Sonia may not project back to the same position. Traverse Mercado often is preferred due to the difficulty in measuring scale and direction on Cassini-Sonia. Application of Cassini-Sonia. This projection has been used for over 100 years and shall continue to be used for cadastral surveys in the new geodetic frame. For now, it is used in Cyprus, former Czechoslovakia, Denmark, Malaysia, and the former Federal Republic of Germany for large-scale maps of area predominantly north-south in extent. There are 9 state origins used in the coordinate projection in the cadastral system of Peninsular Malaysia. One of the mapping equations is given in Richards or Eller in 1974, and the formula to derive projected easting and northing coordinates, where NE is equal to it represent the compute Cassini's coordinate, Fe or Fn representing the Cassini state origin coordinates, A represent lambda minus lambda 0 multiply cos phi, that the lambda are equal to longitude of computation points, while the lambda 0 equal to longitude of state origin, and phi equal to latitude of computation point, and the last is t, that is equal to tan to phi. The conclusion that our group have made for this assignment is the determination of a position requires the choice of a coordinate different system. Until recently, an in-depth knowledge of coordinates and datums were generally confined to users with specialized knowledge in surveying. However, the development of techniques such as GPS has made available entirely new methods of acquiring accurate coordinates. A situation now exists where it is common for users acquiring data by using a set of coordinates that is completely different to the one in which the data will be ultimately required. In order to make the coordinate system in our country better, Japan in Malaysia will continue to monitor the geodetic infrastructures for any significant displacement and procedure updated parameters to relate the various coordinates accurately and timely. That's all for our presentation today. I hope everyone can enjoy the video we have made. Thank you everyone.